marker is open. I gave you. Somewhere there's a marker drawing out. Okay. So we had a variable. It's waiting for an address. If I dereference it, I get a student. So, and what does new student do? It gives it an address of a new student struct. And we have a second variable called head, and head is initialized. What does that mean? That means right now we've got an empty list. What should pop into your mind is that we're going to have a picture that looks like this. We have a variable called head. Head is going to point to the first item in the linked list. That's going to be linked up to the second item, and that'll be linked up to the third item, and eventually we'll have, so again, this is student number, name, and next. Student number, name, and next, and way at the end, next will have a 0 in it, meaning that we've reached so that the address will be 0, which means that there isn't another box beyond. So this is a linked list, and traditionally you call the variable, so this is a variable. All of these things here are probably being created with new, so they don't have their own pointers. Okay, so to begin with though, head starts off with a 0 in it, meaning we don't have anything in the linked list. There's nothing there. Okay, so you were supposed to, problem 1, you were supposed to put 17 into the SN, the student number field of NS. So this is what we were given. And so NS, the student number field of the struct pointed to by NS. And so what I was looking for was one of, so here we've got this variable NS. And so NS is the new, so NS points to a struct, a student struct, that has in it student number, a name. What's inside of the student number now? Garbage. What's inside of name? 50 characters, and each of these 50 characters is filled with garbage. And then we have the next. What's inside of there? Well, there's some bits there, so that's, you can treat those bits like an address. It points somewhere. Okay, you're supposed to put 17 into the SN field of the struct pointed to by NS. So what kind of thing can you put over here on the left? Well, you're used to putting variables on the left. You're used to putting, you know, if you have an array, you can say A brackets 7. You can put in so what belongs on the left is a variable, an array name, or you can have a field out of a struct. So one possibility is, yeah, we say NS, we dereference it. So NS itself is a pointer. Asterisk NS is the struct. So NS is an address. Asterisk NS is the actual structure, and then which part do we want? We want the student number part. So this would be one way to write it out. The other way to write it out is you say NS dash and a greater than. So arrow SN equals 17. So you can have things like this on the left-hand side of an assignment. C makes a really big point about what things you can put on the left-hand side of an assignment. It calls them L values. The L meaning left. So what type what type of things can you put on the left? Variables, array bracket something, or a struct. So this thing is a struct dot sn. So this statement here, I was expecting one or the other of these two for problem 1. And he got it all right, and he got it all right. I don't think they were really sitting right next to each other. They probably didn't copy from each other. At any rate, then there were other people that did pretty well. So one or the other of these. So an L value is something that it's basically it specifies what belongs on the left-hand side is a place in memory, because you calculate a value over here on the right-hand side and then you put it someplace in memory. So an L value specifies someplace in memory that you are putting whatever was on the right-hand side of the assignment. Okay, that was number 1. Number 2, you were supposed to put the value in head. So put the value in head into the next, that's this field here, the next field there. Now I've got it spelled right, F-I-E-L-D. The next field of the struct pointed to by ns. So we're putting something into the into next. That's this thing here. So I want to put something here. We've just put something. We just put a 17 here. And so now we're putting something here. What are we putting next? Whatever value is in head. So we're going to have an assignment. We're copying out of head, and then what appears over here? Well, this or this, but not with SN, instead with next. So we asterisk SN dot next, or SN arrow next equals head. So your choice about what you put there. Any questions on this? Yes?
I thought it was supposed to be pointed by NS, not SN.
You're putting the value in head into the next field pointed to by NS, right? So, oh, yeah. Thank you. Okay. That ought to be worth a point more. That I can fix. There you are. Worth a point more. Yes. Thank you. That was very useful. So asterisk NS. So that's the pointer. So so NS is the pointer. SN is the student number. And down here. Thank you very much. There we go. Okay. So those two. And then the third thing was you're supposed to put the value in NS, put it in head. So that's so the value in S goes into head. So that's going to be head equals NS. So no need for asterisk. These two things are the same type of thing. What are they? NS and head are places for addresses. So what's happening here, I'm taking the address in the NS and putting it into head. What does this accomplish? Doing steps 2 and 3.
It assigns the address of the previous box.
Yeah, so we've got here This isn't, completely idle work here. We're starting off. Here's head. Head is starting off with a 0 in it. Then we do this step here that does what? It makes a new box, and we carry out this step here. So let's take a look at what that's doing. We have ns. So right down below here, I've got variable ns. It points to this thing consisting of a place for a student number, a place for a name, and a place for next. And what are we doing when we're doing this step here, we're taking whatever's in head. Well, what's in head is a 0. I'm copying that to here. So when we do this, that statement 2, then ns arrow next equals head. It copies the value here down here. So that's step 2. What about step 3? We are taking the value, we are putting the value in ns, we're putting it into head. So what value is down here? Well, the value that's here is the value we got from this. It's the address of a struct, and so we're throwing out the 0, and so head now, originally our list was empty, but now head points to this first item. Suppose you were to repeat these 2 steps now. So that that we're going to make, okay, so what are the steps? The steps are we're going to do this, we're going to make a new box, so ns is going to be equal to new stew. ns is going to be equal to new stew. ns arrow head, sorry, ns arrow next equals head, and head equals ns. We're going to repeat this over and over again. What happens? I mean, I might add something else on, we get ourselves a new box. We then, so right now head comes down here. So we do these 3 things here, and head is now hooked up to our first box. And now we come back up, and ns now will have in it, the next time we do new, we get another new box. That's what's nice. Each time you ask the operating system, give me a new box, we'll get a new box. Okay, so we'll have, that was my new box, but now is my new struct or box. We're going to put into the next field here, we're going to put into this next field what's in head. Well, what's in head is the address of this box we've already got. So what we're going to have here, in our new box, we're going to have the address of this box, okay? I'm copying from head down to here. So this box now, this box is linked up to the first thing in our list. That's this. And then we're going to say head equals ns. So the last thing that we do is we copy the value in ns, which is the address of the new box, and we put, so what was here, which is the address of this guy, so head now has in it, instead of having this in it, head has in it this. So take a look. Head has in it the address of this box, and with whatever data it has, is linked to this box, and this box is at the end. So what's going on when we do these 3 steps? We're inserting a new box square at the beginning of the list. So these 3 steps here insert a new box beginning of the list. Head marks the beginning. What's inside of head is the address. So we originally had 0, and then we had the address of this guy, and we took the address of this guy. When we got a new box, we took the address of this box and put it here. That was this line here. Head had in it the address of this box here. And then head now has in it the address of the new box. So when we go, so now head has in it the address of the new box, and the next of the new box has the address of what was previously the new box. And then what's in the next here is 0. So each time we carry out these steps, we're inserting another new box at the beginning of the list. And we did that, right? I think we... No? Okay, you get to see that. My screen is still blank here. Here, I guess our boxes are a little simpler. All we've got is a place for data, so int data, and then we have what? The second thing, if I dereference it as a box, so it's a place for an address of another box. Okay, we're down here in main. Head is starting off with a 0 in it. And now take a look at what's happening here. The very first line is we get a new box. So here it's new stew because the name of the struct was stew. Over here, we're calling our struct box. And so we create a new box. We've just done a scanf. And so we store the whatever input, we store it into the data area of the box. And we then do what? We do this line here. New box, arrow next is head, and the last line is head equals new box. So this is stuff you want to know how to do.
I got a question.
Yeah.
For head, why not just use a traditional integer? Why do we have to use the structure box or an address?
How much, so if the possibility is that you could store stuff, well, I think what you're saying is store stuff in an array, right? Store the numbers in an array.
No. Like, since our head is serving as like a temporary address holder, right?
Well, it's more than that. It's saying where the first
Yeah.
box is.
Why do we have to use a structure for that? Why can't we just use an integer since it's only an address? We're using it as an address, right?
Yeah, but we want to store all the data, and so each piece of data is linked up to the previous piece, which is linked up to the piece previous to that. So what's happening here is that we are getting data until we run out of data, or either the user gets tired of entering it, or we get to the end of the file. Yeah, and so while we get data, I want to store it somewhere. So one possibility is I get my first piece of data, and I store it at index 0. Then I get the next piece of data, and I store it at index 1, so that I keep track of my. We have A brackets I, and then we do I plus plus. So the next time around, we'll store in the next location. That's a possibility. except here you have to know kind of, if you're using an array, you have to know how much data. So the point is, we're getting multiple data items, and if you are going to use an array, you have to say A brackets 100 or A bracket. You have to have some idea of how much data you're going to have. And so with the struct, we have enough room to store the data, and we have a pointer to the next item. Again, 0 means stop. So the only limitation here is you might ask for a new data item, and the operating system might say, well, you've run out of memory, I'm not giving you any more. That could happen. So the reason we're doing this is so that we can store any amount of data, essentially any amount of data that we want, and we don't have to declare an array with a size first. Instead, each time we are successful, each time scanf is successful with getting a number and putting it into X, scanf returns a 1, meaning we've got one more data item. So these will be equal, and so that's true. And so then so when that happens, we ask for a new box, we put the data into the new box and continue. So think about this, that maybe it's more complicated than just a single a single. What am I trying to say? It's more complicated than just a single integer. So I'm not quite sure what's bothering you. The idea is that we have lots of data to store, and with this way of doing things, we don't have to declare an array to store all the data. Yes, no, or
Yeah.
okay. Let's look at a slightly more complicated thing. Let's take people's names. Okay, so let me get some. This is kind of like our first linked list. Oh, wait, I guess there's one more thing to show. You want to print out the data in the linked list. So let's talk about that. The only variable that we have, it's kind of like this stuff is all hidden from us. The only variable that we've got is head. So what is head? Head is the address of the first thing in the list. So if you want to print out everything, it's not like you've got, A brackets 1, A brackets 2. We don't have that. All we've got is head, which tells us the address of the first box. So so let's look at this portion here. We're setting up another variable. Well, again, it's a place for an address of a box. If I dereference it, I get a box. So I'm calling it current. So current, what's current going to have in it? Current is going to have in it the address of the first box. I want to print out the data there. So here's the print statement, print %d. And what are we printing? We're printing out current arrow data. So we're printing out what's inside the data field. And we can do this. There's always a chance that the address will have a 0 in it. 0 is not the address of a struct. 0 just means stop. So notice what we say here, while current is not 0. So if we get inside of this loop, we know current is not 0. So it's a real live address of a box. So when we say current arrow data, we'll be getting the data out of a box. What does this do? Well, we're changing current. If current has the address of this box, current arrow next, if current has in it the address of this box, current arrow next has in it, what's stored here is the address of the next box, which is this one here. So what are we doing? This right here. So this is a pretty important line. This moves on to the next box. And so that's the new value in current. So what do we do once we get a new value in current? We go back up to the top of the loop and check, is current not 0? remember, eventually we'll get to the last box, and the last box will have a 0 in it. And so we print out the data in the last box, but then current equals current arrow. The next will have a 0 in it, and so when we go back up, we only keep on going so long as current's not 0, but it's 0, so we quit. So this is so it would be really good then for you to know this, because I'm thinking about asking some question on this for next time. Any questions on this? So that, what was that? That's this linked list. Linked list C here. Say we wanted to store these things in numerical order, or maybe we're getting a bunch of names and we want to store the names. So the names are going to come in randomly. So I'm going to, here's linked list 2. I think we've got enough time to do it in here. I'll just call it LL2.c, linked list 2.c. So here's our struct. So our box, you don't have to call it box. Our box is going to have in it a place for a name that has to be. So we're assuming the name is going to be less than 50 characters, and something that takes us on to the next. So again, these names, you can call them anything you want. So we have two fields, a field called name and a field called next. Okay. So we're going to have head. The box, asterisk, head, we'll set it equal to 0. So what's main going to do? Main is going to get a name, put it into a box, and then put it in. So main's job here. So it's going to do the following thing. It gets a name, puts it into a box, puts the box into the list, so the things are going to be sorted alphabetically. Puts a box into the list so that the names are sorted from smallest to largest. And we keep this up, so we're going to keep getting names, and then at the end, the last step will be to, so this, we're going to loop here. So it gets a name, it puts it into the box, it puts the box into the list, so the names are sorted from smallest to largest. And last step, print out the names in the list. Okay, so since we're looping around, we're going to say something like while. So 1 equals scanf. What we're looking for here is a string, so that would be what? %s. And I need to put it somewhere, so let me set up something to put it. So we're going to have char I'll just call it input INPT brackets 50. So So down here, you say scanf INPT. Okay, so that's an address, so that's okay for scanf. So what have I just done? We've just gotten the name. Okay, so we've accomplished, gotten the name above. So we need to put it to a box, right? Well, we need to make the box. So we better say something like box asterisk NB equals new box. And now we need to get the name in there. What do you do with name? The name that's got a whole bunch of characters in it. We need to copy them all. And so we're going to say down here, string copy into NB arrow name this INPT. So I'm copying the characters out of INPT. I'm copying them into NB arrow name. Now the question is, where do we put this box? So maybe maybe the linked list looks this way. Here's head. Head has in it our first box, and maybe that's got Alice in it for a name. And Alice is linked up to Dan, so the name field here is Alice, the name field over here. Dan, and Dan is hooked up to Homer. And then our new box in B that's got like, maybe that's got Bob in it.
Now, do you have to initialize NB before you can use it?
This statement,
Oh, I see it now.
right here, this is, yeah, so,
And then after next, do you need to have a semicolon way up top?
yeah, that's what, a colon?
Yep.
Thank you. Anything else? Oh, that was good, very good. Do you think you deserve a point?
No. I know I did bad, so.
Okay, there. Okay, so moving along here, there's that new commercial for Time Warner where they keep saying, well, you've been good because you wore cool shoes. And you see that commercial? What?
Sounds weird, but
Well, the idea is that you deserve high-speed internet. Everybody does, yes.
I'm one time I live pretty decent, so.
Okay, so our problem is with Bob is I don't want to put Bob at the beginning of the list because the list won't be sorted anymore. I want to put Bob here. So what has to happen is this. And if instead of being Bob, suppose it had been Elmer. Okay, so I'll stick with Bob here.
I'm confused. On the program, you have it worded order going to sort it from smallest to largest, not alphabetical order.
That's what I mean. Okay, alphabetical. You like that?
Small, I thought you were talking about characters now.
Yeah.
So the names are sorted. Is that right? Alphabetically? Yeah, there we go. Are sorted alphabetically. There. Okay. So if instead of being Bob, it had been Elmer, then this box would, then we would have had to put it over here like that. So what do we have to do? We have to search. The reason we don't put it before Alice, I mean, there are names that come earlier than Alice, right? I can't think of one right now. Abby Ankar, A-B rather than A-L. There, Abby Ankar, there. So we keep on searching until we come to a name that comes after us alphabetically. Or we get to the end of the list and hit a 0, and then the name belongs at the end. So to find out where this name goes, we have to do a search through the list. Okay.
We have to have a swap function.
We have to do a what?
Swap function.
A swap function? No, that's the great thing, is that each time we get a new name, we just put it in between two other names. Or we either put it all the way at the beginning of the list, or we put it between two other names, or we put it all the way at the end of the list. We just put the new box in, and we change a couple pointers. Take a look here. If it's Bob, right now Alice is points to Dan, to the box with Dan in it, but instead we'll change the next field here so that it comes down here to Bob, and Bob will point to the box with Dan in it. So that's an advantage. There's no swapping. We change pointers. If this box were Abby Ankar, it would belong before Alice, and so I'd have to change head. Okay. So what we need to do is we need to go down the list. And so how do you go through a list? You say something. So here's where what we're doing now. Okay, so this is what we want to do. Okay, we want to do these two things here. The way that we're going to accomplish that is we're going to run out of time, so we're going to search the list. For a name larger. So I'm hoping you understand what this means now. Larger than INT. Okay. So how are we going to do that? We're going to start off by saying box asterisk current. We're going to start at the beginning of the list. So again, and while, how do you compare two names?
String compare.
There's something called string compare.
Yeah.
Man, STRCMP. String compare. So it's that one right there. You compare the first guy to the second guy, and it returns a number, an integer, that's either less than 0 or equal to 0 or greater. So it returns a number that's less than 0 if the first string is smaller. It returns 0 if the first string is equal to the second. It returns, so S1 and S2, it returns a positive number if the first string is greater than the second. So what we're going to have to do then, okay, so your next project is going to involve, I'm going to do the insert, and guess what you're going to have to do? You're going to have to do a delete. That sounds like fun. Okay. So, sharp include string.h, and we certainly are going to need sharp include standard io.h. And so we want to keep on going while string compare of INPT, we're comparing that to what? Cur arrow name. I'm going to let you go in like about 30 seconds here. We're going to do the string compare. And if the input is smaller, that would be good. But if the input is larger, you know, why do I want to move beyond Alice? Because Bob is the input here. Bob is bigger. Or if it's Elmer, Elmer's bigger than this. Elmer's bigger than Dan, but Elmer's not bigger than Homer. So while the input is bigger, bigger is what? Is greater than 0. So string compare returns a number that is bigger than 0 when the first guy, when the first plugin, so if it's bigger. And the other thing I worry about is we might run out, right? It could be that current is, we want to do this while current is not equal to 0. If current's equal to 0, all bets are off. We've reached the end of the linked list. So while this happens, what do we do down here? How about current equals, current equals current arrow next. So we'll talk more about this. This isn't complete yet, but we're going through the list. We're going through the list so long as the input is bigger than what's in the list. So if the current input is bigger than what's in the list, we need to move further in the list. And so we're either going to stop because that isn't true anymore, or we've run out of boxes in the list because maybe, you know, if Homer's the last thing and it's Xavier, maybe Xavier Saunders, I think he's around here somewhere. Xavier would come after Homer and would belong at the end. So current would become 0. Okay, so we're going to fix this up tomorrow. And I'll leave you with a problem to do deletes. So, okay, that's it. See you. Yes. Yes. Yeah, you are.